So I've been coming to LISA since LISA IV. And that was back in the 80s. I don't know how many years, 80-something. So at that point in time, I was a system administrator. And then I don't know how it happened. There was a logical progression. And now my job is a full-time release engineer at Google. And I've been there 5 years. I've been involved in release engineering for about 14 years. And one of my passion, I guess passion's the right word, is packaging. I'm fascinated by different package managers, different ways of doing packaging. And so today I'm going to talk about Google's package manager and talk about how it works and some of the features I like about it and some of the features I don't like about it. And my intent is to maybe get you thinking differently about how you do packaging. If there's anybody working on open source, maybe thinking about improving some of our existing package managers, because there certainly is room for improvement. If you, we had a one-day summit on release engineering on Monday, and there was a talk on, I'm going to paraphrase the talk. It's basically how awful package managers are, but they're better than anything else. And it's actually pretty entertaining. So if you get a chance, go, when the talks are posted, go take a look at that one. So what's the problem? This actually ties in really well to Dan's talk because he actually talks about some of these issues in his. There's bottlenecks, right? This is nothing new. Regardless of the size of your network, all of these are issues. But when you look at a network the size of Google, the issue, one, the chance of any of these happening is pretty high because we have so many machines. So we have to worry about bottlenecks. We have to worry about latency. You know, you push out, you have a new package that's ready. How long is it going to take until that package is available to all of your machines? And depending on what the package is and what the change is, if it's a security fix, you know, you want to get it out there pretty quickly. Machines offline. If machines are offline, when they come back up, you want them to be able to know that there's new packages available and that they need to install them. Partition networks. You have networks that, because of failures in hardware networking devices, one network can't talk to another network, but yet you still need to be able to push out changes to the machines in those networks, even though you've got partitioning problems. And if it's a very serious partitioning problem, it's basically equivalent to the machines being offline. And so when the network comes back up, then you have the same issues. Concurrent writers. It's possible for there to be concurrent updates. We can have two people build the same package at the same time. And our package system has to be able to handle that so that if someone fetches a package, they get what they're expecting. And we don't get this situation where the metadata of one package is being pulled down with the data in a different package. So I'm going to talk about that too. So Google's package manager is called Midas. We refer to her internally as MPM. And is Noah here? There he is. My motto is, don't forget to bring an SRE. And so I have one of the SREs from the Midas team here to help with questions at the end. And both of us will be in the booth after this too if you have additional questions if we run out of time. So the package metadata, and I'm going to talk about what makes up the package metadata in a little bit. It's stored in our Bigtable database. And we've talked about Bigtable publicly. There's papers you can download that talk about the Bigtable design. But basically, it's our own proprietary database. I mean, anything we talk about at Google, I could probably, the words own proprietary are probably implied. The package data is stored in our Colossus file system. Again, we've publicly talked about Colossus, and there's papers you can download if you're interested in more information about it. The transport mechanism to distribute packages, it uses it's a peer-to-peer communication, and it's based on torrent technology. And okay, so this talk does not apply to Android. This talk explicitly is for our Linux-based production machines. So Android has its own packaging package manager. So what are the characteristics of an MPM package? Well, first there's the contents. I mean, the stuff, the only reason to have a package is because you've got something that you want to be installed on your machines. There's a unique version ID. This is a long hash that begins with 1 dash. I don't know why they all begin with 1 dash, but they do. And it's generated when the package is created, and it's unique, and it can't be changed. Signatures. Packages can be signed electronically. And that's very useful when we have packages with sensitive data in them, packages that fall under SOX controls. But basically, we can apply a signature that tells us who created the package and, well, who signed the package and when. We'll talk more about that later. Labels. Dan talked about labels and had some good examples of how we use labels in our production environment. But basically, a label is a string. And we have our main automated build system that we use allows us to a lot of flexibility in what types of labels we use. And each project can use its own variation of a label, whatever makes sense for their release process. And often the SREs are the ones dictating which labels that we use in production, because it needs to be clear what version you're actually running of a binary, and how do you tie that back to the NPM it came from. The last label is a special type of label that I'll talk about a little bit more, the one with the equal sign in it. You can have pre-packaging commands. Our packaging is built into our build system. We have a proprietary build system with build files, and it's actually built into it. So you generate a package using, you specify a package target, and then all the dependencies and the binaries get built automatically. You don't have to individually specify each binary. And then there's optional pre- and post-installation commands, like many RPM and Debian and some of the other package managers support those also. So here's a case. This is actually a real example. We've got configuration files that we need to distribute to. I use the word thousands because they let us use that word. Dan alluded to large numbers, and they are large numbers. So we package the files up into an NPM. And then there's jobs on the remote machine. I'll talk more in detail about what that means. We use the word fetch instead of install because that's just our terminology. So when I see fetch, just think install. It fetches a new version of the package every 10 minutes. And we do that so that we can push configuration changes out for this particular application very, very quickly. And then there's a post-fetch script that actually copies the configuration files to where the application on the machine that needs them is expecting to find them. So this is a pretty straightforward example. Everybody has some kind, some configuration file that you want to push to all of your machines. So let's see what actually happens, and then we'll come back and revisit this case study. Like I said earlier, there's always going to be offline machines. We have to assume that, and we can't have catastrophic failure on generating a new package because machines are offline. And we want those machines to be able to know there's a new package when they come back up. We need to minimize bottlenecks. We spend a lot of time at Google trying to make sure there are no bottlenecks, because when you do things at the scale we do, you just can't have a lot of bottlenecks because things would take too long to propagate. So the job is the one that determines which version of a package to use. And when I say job, I'm talking about a process that's running in a container. And so you can have multiple containers on the same machine. And so, and the jobs on the same machine can use different versions of the same package because they basically fetch them into their own space. We have to be able to guarantee that the packages have not been tampered with. This is particularly important when you've got encrypted files, which I'll talk about. And as Dan demonstrated, we've got to be able to very, very quickly roll back to a previous version. And there's a lot of magic the SREs do with labels that allow us to do this very, very quickly. So for a package creation, the first thing that happens is the build system generates a package definition file. We've got some corner cases where the build system can't support everything we need in the package definition file, so those are just static package defs that are checked into our source code repository. But 95% of the packages out there, we generate the package definition file automatically. And it contains a list of files that are included in the package, ownerships and permissions, any pre or post install commands. So what we do is we basically run a build command, just like we're building a binary. And it generates the package def, and then it generates the and all the dependencies, all the binaries, and then it creates the package. And then you can apply labels or signatures at any point in time. You don't have to do it at package creation. A new MPM determines when you create a package, it checks to see if the files going into the package have actually changed. Now for our binaries, particularly ones done with the build system, it almost always results in a new package because we embed version information with each binary that includes build times and any build labels. So that's going to result in MPM thinking it is a new binary, even if you had built the binary at the same CL in the source code repository. But for configuration files, certainly, because they're just ASCII files, if they have not changed, MPM will not create a new package. You don't know this. You ask it to generate a package, and it tells you, but it's not it's informational. It's not a fatal error. And if you requested any labels, it will apply them to the package, so that if you want to call it with today's date, the existing package would get today's date, and so any testing that you plan to do and so forth would work because you could reference that label. And so this is something we do for efficiency purposes and to save space. There's no point in creating a package if it hasn't changed. So I talked about the metadata. The metadata is we have immutable and mutable metadata. The immutable metadata is basically who built the package, what time, how was it built? Was it built with our build system? Was it built from the command line? A list of the files that went into the package with their checksums and file attributes. And some labels are immutable. Labels with an equal sign in them are immutable. Once you apply this label, it cannot be changed except by somebody on the Midas team. And there's special labels. Latest is a special label. Anytime I build a package with a specific name, it gets a label of latest. So you can actually fetch any package with and reference latest and pull it in. Mutable metadata are labels. Labels, except for the one I showed here with the equal sign, they can be moved around from packages. So if I have a package named storage, I can apply a label with today's date. And if I build one later today, I can apply a label of today's date to that one, and the label gets deleted from the first package and applied to the new package. So within the same namespace, a label is unique. And a cleanup policy. I'm going to talk about cleanup policy in a minute, but we can change the cleanup policy associated with an existing package. So durability, we have lots and lots of packages, and we don't want to keep them around forever. So developers can generate test packages with durability of test. And they have a default retention of 3 days. We don't push these packages to production. And it's basically for the developers to make sure that the package has the contents they want before we start pushing to production. Ephemeral packages are short-lived. Well, they're longer than 3 days, 7 days. And these are used, configuration files are created ephemerally because their configuration files get pushed out frequently. I'm using an extreme example of every 10 minutes. And so we don't need packages from longer than 7 days ago laying around. Durable packages are what most of our binaries are that make it into production. And the default retention is 3 months since the package was last used. And then after that, they get archived onto tape. So we do technically keep them around forever, but they're just not taking up resources on our machines. And we have a way to go in. I go in and actively see what jobs are using my MPMs. So for distribution, like I mentioned earlier, it uses a pool method. So the jobs get to decide if they want a new version of a package. This means one advantage of this is it avoids network congestion. If I create a new package, it doesn't get pushed to all the machines at once. And so this helps us avoid a bottleneck. And the new job owners, you don't necessarily want to interrupt a job and push a new package because it might be, something important like, Google Web Search. And so it's up to the teams and the SREs to decide how they want to do the updates. And as Dan talked about, we do phased updates. We don't update all the jobs at once. There's some kind of rollout process. And it varies wildly depending on the application. The cons are, job owners can decide when to accept new versions of a package. I support one project, and we have people running 2-year-old versions of the MPMs. And we tried deleting them, and people screamed and yelled. So sometimes it can be frustrating because you want to get rid of older versions of the packages, and people are still using them. You have to have extra logic in your process of running your job to determine whether or not there's a new version, or you have to use one of our rollout tools to push new versions. But there again, you have to know that there's a new version out there. Something has to, either a person or the job itself. And it can be difficult to predict who's going to use a new version of a package when you're pushing it, or when you're creating it. And so a lot of times the developers work hand in hand with the SREs to decide how it's going to be rolled out based on what's in the package, what changes there are. So the metadata, I talked about Bigtable earlier. The metadata itself is stored into Bigtable. And it's replicated. When you create a package, the metadata gets pushed out to a Bigtable immediately. So everybody knows right away if there's a new package. We have root servers that can read and cache the data from their local Bigtable. So we're not hitting the MPM client is not hitting the Bigtable servers all the time. There's MPM root servers that have this information and caches it. If a request fails, transparently, the request will be sent to another MPM root server based on geographical location in the network. So the package data is stored in our Colossus file system. And we have replicated Colossus servers all over the world. We use a 2-tiered architecture for distributing the MPM packages. Frequently fetched packages get cached locally or nearby in the data centers. And so that way we aren't frequently, there's some packages all jobs use. And so those get cached closer to the job. Less frequently frequently used packages are on the first tier, or the higher tier, I guess it'd be correctly. The package data is stored locally. So as long as you continue to use that version of the package, you no longer need to talk to the MPM servers or Bigtable or Colossus. You've got your local package. If multiple jobs on the same machine are using the same package, there's only one copy of it. We do millions of fetches daily, and it's petabytes of data. So it's a lot of data. It's very, very fast. I mean, when I create a package, I can fetch it almost instantaneously on any machine in production. So it's very, very fast. If your local Colossus server doesn't have the package data yet, because the Bigtable, the metadata is pushed out immediately, and it's very, very fast. It's not a lot of data. If your local Colossus server doesn't have it, transparently, it will get it from one that does. So what you see is the fetch takes a little bit longer, but the package is there, and it is available to you literally almost instantaneously. So security. The package, here's some example of package names. The namespace is hierarchical. So here I have storage client, I've got storage client config. Both of these are names of MPMs. We have access control lists, and they're inherited. So if I can put access control lists on storage, and storage doesn't even have to be an MPM, this is just a namespace. And then those can be inherited or not. You can turn off inheritance by all of the packages under the storage namespace. So you don't have to go apply your ACLs to all of your MPMs, but you can base them. So you can think about your naming and creating your ACLs and come up with something that makes sense. There's three levels of access. We've got owner, builder, and label. Owner is basically they can create new ACLs, they can create packages, they can delete packages, and a builder can only create packages and add and modify labels to a package. And then we can actually control we can put specific controls on different types of labels. A common thing we do is our build system applies production labels to packages. And so we can actually restrict who can apply a label that begins with production dot on a package. So that's one way we work with the SREs. It's like, for some projects, don't deploy any MPMs into production that don't have a production label, because that means they didn't come from our build system and weren't built in a consistent, reproducible manner. Encryption. Individual files can be encrypted. And the NPM servers cannot decode the information. And there's ACLs associated with the package that determines who can actually decrypt the files. And so this is one way we can get passwords, or if an application needs secure information, we can decrypt it and package it into an NPM and make it available in a secure manner. So I talked about signatures. A signature is basically a way of anybody can apply a signature to a package, and it's just a way. The most common use is from our secure build system. It will sign a package, and then we know, oh, this package was built on our secure build system. We know it has a higher degree of security because it was built in a certain way. And so you can actually fetch packages and verify the signatures before you actually deploy them and start using them. So if you need package to be signed, we have a way to check for that. So going back to my case study, so here's what's happening behind the scenes. I request that the package be created. If my config files have not changed, NPM doesn't bother creating a new package. Configuration files, as I mentioned, packages containing only configuration files are ephemeral by default. And so, and we're not going to apply a label to them. We're just going to fetch the latest one each time. The metadata, when I create the package, the metadata is written to big table automatically and automatically replicated. And this is very, like I said, this is very, very fast. And then the package data is copied to Colossus and replicated. But it's going to take a while, particularly, I mean, we have packages that are like, 2 gigabytes, or I forget what's the maximum a package can be? It's something like that. Huh? Yeah, there's a limit, or at least it complains. And like I said earlier, if your local Colossus server doesn't have the package data yet, it will be fetched from one that's further away. And so the fetch just takes a little bit longer, but it's transparent to you. So how do we update every 10 minutes? It's really nothing too magic there. We have our own cron-like system. And we have because the jobs get to control when they get the update. And so basically for this application, we have a cron-like job that just runs every 10 minutes, pulls down the new package. If the package hasn't changed, it's a no-op, but it's transparent. And if the package, if another job has already fetched that package on that same machine, it's not refetched. It just uses the data that's already local. So we don't end up with, X number of copies of the same thing on the machine. So what do I like about MPM? We have a tool called MPM Diff, and that allows us to literally compare any two packages. They don't have to have the same name. It can tell me, I can ask it to tell me, are there differences in the file owner and mode? File size. I have found that unexpected changes in file size can expose problems with your build system, because maybe you accidentally are now including debug symbols in your file when you weren't before because someone changed a build flag. So I like doing this, doing it automatically as part of the release process, because I found it can detect problems early in your build process. You can have it can compare post-install and pre-deinstall scripts. And this can be useful too, because these are just shell commands that run. And so maybe you want to, on a particular NPM, you want to monitor to make sure someone hasn't interjected a new command that shouldn't be there that's going to run on one of our production machines, because that wouldn't be good. And file checksums. So I think this is very powerful. It's also powerful if you change the name of your package for some reason, because that does happen. You could still go back and compare it to previous versions, even though the name has changed. Labels. Like I said, Dan did a great job of leading into this topic. You can fetch packages using labels. If you really want to, you can fetch them using the really long hash, but no one does this. Actually, I had a couple teams try to do this in their board config files. They really wanted to do that, and I was like, oh, don't do that. So you can also, we use, in our build system, we use labels to indicate where an NPM is in the release process. When we first create an NPM, we usually apply a canary label to it. And then people know, oh, this is the canary version. So if you want to run with the canary version, you can. Or if you see that label, okay, I don't want to use that one yet because it is the canary version. Packages can be promoted by moving labels. Live is one of the labels we use a lot. And so live is the current production-ready MPM that's being used. And so when the Canary version is now ready to be pushed out, we can move the live label from the previous one to the Canary version, and any new jobs coming up would then get the new live version. And I talked about immutable labels. I don't see this used a lot. There are a few teams that do it. You would do this if you don't want the label moved. And so if you come up, but because it can't be moved, you need to choose wisely. We've had some people apply labels and they come back and are like, we want to change it. And the Midas team has to do that. Latest is a special one, like I talked about. When I create an MPM, latest gets applied to that package. And so if you want to, however, though, someone else could also possibly be creating the same MPM. Maybe one of the developers is, and because they're testing something new. And so it's very handy to use latest. It also can be a dangerous thing to do because you aren't guaranteed the one you just did is the latest one. You know, we often will, when we do the promotion, apply a rollback label to the one that we just promoted from. And that way, very, very quickly, the SREs can go back to that one without having to, they know, okay, this rollback or this last known good label, that's the one we had in production right before we did the promotion. And so we see that used a lot. We have the concept of file groups. So it's a grouping of binaries within the MPM, and binaries can belong to more than one file group. I have one project where we have like 20 binaries go into the MPM, and they're grouped together in about 10 different file groups. And some of the binaries, based on the type of job that's fetching them. So different jobs are only going to want 2 or 3 of the binaries, but we wanted to build all the binaries at the same time in the same way. And so that was the solution they came up to. The most common use of file groups are to have a stripped version of the binary, that is the one that's installed by default, and then have a second one that's hidden away in a file group that has all the debug symbols. And we like that a lot because you know, okay, this binary with the debug symbols was built at the same time as this binary. And so when you're trying to troubleshoot, you're guaranteed that, okay, you know, if I run with this one, I'm going to be able to debug it properly. Some teams store the debug one somewhere else, like in the Colossus file system, but it's nice to know you can get them right together. And there's a way to fetch all the file groups, but you can also fetch individual file groups. And then we have a web interface that I wish I could show you, but it's too much proprietary information, I think. But you can browse all the NPMs, and you can basically browse through the namespace, and it displays the metadata. We have a command line, too, that does this, but sometimes it's nice to go in and just, if you're not sure what you're looking for. The command line's great if you know exactly which NPM you want to look at. Sometimes you don't. And it shows you, you know, how it was built. Was it built with the build system? Was it built from the command line? And one of the things I use it for is there's a graph showing you the growth of your NPM over time. And so you can tell if you've got, you know, NPMs seem to never get smaller. They just get larger and larger, right? Everybody experiences this with packages. And so I found that useful. Plus, if we can look and see, oh, wait a second, was this package always this big? And it's like, no, what happened last release? It's like it doubled in size. There again, you know, build flags could have changed, and now we have debug symbols where we didn't think we had them. So that's it. Any questions?
Hello, thank you for your presentation. And my question is, what is the workflow of applying changes is there auto-deploy in testing environment, for example? And should someone make a hook to make these servers apply new packet in production environment? And how do you guarantee that every machine in production runs the correct version of the package? Thank you.
I'll answer the last part of your question first. Is we can't guarantee it because the job owners have control. And so if you want to force a change out there, you basically have to nag people to death, and you have to threaten to turn off services to get people to update sometimes. Anything to add on that? As far as, are you talking about our release processes? They also vary wildly. Google is a firm believer in enabling the developer. And so the developers, luckily we have really good SREs who actually are well respected and are the gatekeepers to make sure that we are using sane release processes. And then my job as a release engineer is to kind of help with the automation effort and help with the tools development. And so we have the concept of cherry picks, where we can take a known good code version at a specific CL. We use Perforce, basically it's Perforce. And we can then cherry pick specific later CLs. And we have an automated build system that people aren't required to use, but it actually enforces workflows. So we can actually make sure that that tests are being run. We also have a continuous testing system where every CL that gets submitted triggers tests. And so basically we're doing continuous testing all the time. However, we insist when we do a formal release that we also run tests, because the flags that are used to actually build what's going into production are different than the flags that the continuous test system uses, just because we have additional information, additional flags that we need. So did that answer your question? We can talk some more too later if you want. That's next question.
So one thing that seems to be missing that a lot of packaging systems have is dependency management. I'm assuming that that's because a package is supposed to be more or less self-contained in your environment?
Yes, to a certain extent. What happens when you actually do a fetch and bring up a job? All the dependent packages actually get pulled in.
Okay, and how does it know what the dependent packages are?
You want to come up here, Noah? Do we have time for him to come up here?
Yeah, we got about 5 minutes.
Okay, perfect. There's 2 mics, so we can share. He's going to give you a better answer than I would.
So in our build system, when you're building a binary, you explicitly list the dependencies or the things that you're importing in your code, libraries, and so forth. And so that's where the dependency tracking happens. But for MPM, it was an explicit design goal to not do dependency management, because you can put whatever you want in the package, right? So that's really where the dependency tracking comes from, is from the code itself rather than the packaging system.
Thank you.
Is this primarily for packages that are actually built in-house? Like, for instance, if you were to pull in a project from another open source project, or, God forbid, a commercial product, because in my environment, we're having a lot of trouble with applications coming from vendors that you have to use the OS layer packaging tool, RPM, Yum, etc.
Yeah. This is strictly in-house. We also use Debians heavily.
Okay.
The production image that all of this is running on top of, we use Debians. And in fact, I have projects I support where we build MPMs and we build Debians, because they're running in two different environments within Google, and we need both.
So your third-party packages, you would still use the Debian package management systems.
Yeah, I mean, without our infrastructure, this wouldn't work. So we would have to reproduce something that would cause it to work.
Fair enough.
So.
Any other questions? I'd like to thank all of you. I hope some of this has sparked some of you to think about giving a lightning talk on Friday. Sign-up information is on the web and also at the registration desk. Thank you much. Enjoy the break. See you at the next session. Thank you, Dinah.